For the fifth video assessment problem, we'll be focusing on logarithmic properties. A real-life application for these properties is represented by problem number 27 in chapter 6-3. When lava flows down the side of the volcano, the velocity of the lava can be measured in miles per hour. For this problem, the equation for the distance from the tip of the crater is y equals 7 times 2 minus 0.9 to the power of x, where y is the distance from the tip of the crater to the point in which the end of the lava is at, and x is the time in hours after the lava started flowing. Part A of problem number 27 asks to find the derivative of the aforementioned equation. To find the derivative, the 7 will be left alone since it is a constant, while for the inner function, the derivative of 2 is 0, so that is removed from the equation, while the derivative of 0.9 to the power of x can only be found using natural log properties. The natural log property that is used states that b to the x power, where b is any real number, will have a derivative, the ln of b times b to the x power. So the derivative of the original equation now is y prime equals 7 times the ln of 0.9 times 0.9 to the power of x. The derivative now can be used to measure the velocity of the lava. To show that the lava is decreasing the velocity, the hours 0, 1, 5, and 10 reuses the value of x. It is shown that as the value of x increases, or the longer the lava has been flowing, the slower the velocity. Part B asks to find an equation of the derivative that has x in terms of y. This means that we need to isolate the x term. To remove x from the exponent, the log with a base of 0.9 is used on either side. Now the new equation is x equals the log base 0.9 of negative y divided by 7, and then 2 is added on. The new units for this equation will now be hours per mile, which is how many hours it takes for the lava to flow 1 mile. Part C then asks for the derivative of the velocity formula found in Part B. To do so, the equation must be in terms of natural logs, which means using the change of base theorem. The change of base theorem states that the log base b of x is equal to the log base 10 of x divided by the log base 10 of b. Log base 10 is then equal to the natural log of the same value. So the new equation is now the f of y is equal to negative 1 divided by 14 minus y times the natural log of 0.9. When f of y is equal to 10, the velocity of the lava is 2.3728 hours to flow 1 mile. Part D then asks to calculate the value of y in the equation in C when x is equal to 10. For this, when the value of x is plugged in, it is found that the derivative is 3.8887. And then in Part E, it asks if these two equations are inverse of each other. The inverse of the answer to Part D results in a value of 0.2572, which was the answer to the original derivative, which was in Part A, when x was equal to 10. The answer to Part D is not actually the reciprocal of the inverse derivative.